Welcome back to 3 Dimensions. In this lecture series, we'll be solving question 11 and 12. So let's start. The first question is find the relative error in Z. So they've given us the Z value. That is A raised to 4, B raised to 1 by 3 divided by CD raised to 3 by 2. So how do we solve this? So let's take a sample question. Okay, suppose we have a question like Z is equal to X square. Okay, so that is a question. So this is a power question similar to the above one. As I said, it's simple. Now, how do you solve this? Like, write Z in form of an error, right? So Z is equal to Z plus delta Z. And this is in the form of an error value. Now, X also in an error. So X plus delta X the whole square. Now solve this, right? We have to find the errors and we have to solve it. Now, you know A plus B the whole square. What is A plus B the whole square? A square plus 2AB plus B square, right? So over here, your Z is equal to X square, right? So both the sides got Z is equal to X square. So we can cancel out because they are same terms. And over here, delta X square is a very small value. The error is very tiny. So when you square it, it becomes even more small. 0.1 square is a very small value. So we can ignore that. So remaining questions, remaining equations, let us write it down. So now divide both the sides by Z. But over here Z is equal to X square. So we can replace Z with X square. Right? So let's replace that. So we get delta Z by Z equal to 2x delta X divided by X square. Divide the X from up and down. Right? So we get 2 delta X by X. So over here we see for Z equal to X square question, the relative error delta Z by Z is equal to 2 times delta X by X. Okay. So, if you have a power above, all you have to do is write it as a constant and then do the relative error. So, relative error was Z is equal to the power 2 becomes a constant into the relative error of X. So, suppose we have an equation Z equal to X power N. Then, the answer will be error of Z by Z equal to N times delta X by X. Delta X by X is a relative error. So how do you solve this question? So you got delta Z by Z, that's the error, right? Delta Z by Z, that is the relative error, is equal to 4 times delta A by A. We know in the case of multiplication division, we have to add the errors, right? We're writing the power down in the form of a constant here. So A plus 1 by 3 delta B by B plus C. The power here is 1, right? So it will be delta C by C. The D has a power 3 by 2. So it becomes plus 3 by 2 delta D by D. So this is a solution. So let's solve example 12. The question here is the time period of oscillation of a simple pendulum is T equal to 2 pi root of L by G. Measured value of L is 20 centimeter. It is known to 1 millimeter accuracy. So this 1 millimeter accuracy is the error. Now how do you convert millimeter to centimeter? There's a small trick that I use here to remember. So this is how it goes. Monkey died, mother come, mum, mum, mum. Okay. So I write the starting letters of the words and join the last 2 letters. So millimeter, centimeter, decimeter, meter. Okay. So if I have to go from meter to millimeter, I have to multiply. If I have to go from millimeter to meter, that direction, it is division. So for example, if I want to convert from meter to decimeter, I have to multiply by 10. Meter to centimeter, I have to multiply by 100. Meter to millimeter, I have to multiply by 1000. But in case if it's from millimeter to centimeter, divide by 10. Millimeter to decimeter, divide by 100. Millimeter to meter, divide by 1000. Now, in this question, we need to find from millimeter to centimeter. So, how do we do that? Divided by 10. So, let's do that here. So, we get L is equal to 20 centimeter plus or minus 0.1 centimeter. Because you're dividing 1 by 10. So, you get 0.1 there. Now, they've given the time for 100 oscillations. So, N is equal to 100. And time is found to be 90 seconds. That is small t. Now let us find with 1 second resolution. So small delta t is 1 second. Now what about the time period here? So t, capital T, that is a time period, is equal to small t by n. Now to find the error, you do delta t equal to t by n. Now if you find in the relative error, it will be delta t by t. Capital delta t by t will give you small delta t by t. So what is the value of small delta t here? 1 second. 1 second resolution. What is the value of small t here? 90 seconds. So we get delta t, capital delta t by t equal to 1 by 90. Now you have to find out what is the accuracy in the determination of g. So we know from the formula t equal to 2 pi root of L by g. By rearranging, we get g is equal to, rearrange it, so we get g is equal to 4 pi square L by t square. Now, in order to find the relative error, you just have to do delta j by g equal to that constant, just leave it for the time being. Do delta L by L plus power comes as constant. So delta t by 2 into delta t by t. Now insert the values. We need to find the percentage error of g. So what is delta L value? We found out 1 millimeter, that is 0.1 centimeter. L is 20 centimeter. 2 times, what is delta t by t value? 1 by 19. So solve this equation and we get 0.027 as the value. Now if you want to find the percentage error, you have to multiply by 100. So we get 2.7%. But we can round it off to 3%. Why? Because it's 2.7. It's the 0.7. 7 is greater than 5. So we can round it off to 3. Thank you for tuning in and stay tuned for more lectures.